right, let's do some homework. Chapter 2, number 11. Write the symbol for each of the following ions. Okay, so we have some ions. What does that mean, ions, to you, Fred?
Different number of protons and electrons.
That's right. So if this ion has a +1 charge, what does it have more of?
More positive, more protons.
That's right, more protons. If the atomic number is 55, what does that mean?
That's the number of protons.
That's right. So which element must it be?
Do you have your periodic table?
Yeah, let me bring that up here real quick. 55, element 55. Cesium.
Okay, cesium.
All right, so 55 is the atomic number, mass of 133. What does that mean, mass of 133?
That's the mass due to the protons and neutrons, so it's the sum of protons and neutrons.
Very good. So how many neutrons must it have?
Is that like 133 minus the 55?
Very good. I'm doing it on my calculator now. 133 minus the 55, so that's 78 neutrons. So we got 55 protons, 78 neutrons. Now how many electrons?
It has a +1 charge, so it just has one fewer.
One fewer than what?
The 55.
So 54 electrons?
Yeah.
Very good. So cesium, the 55 goes down here. That's the mass number, or sorry, the atomic number. And then the mass number goes up here, 133, and then a positive charge there.
Okay, got it.
All right. 54 electrons, 53 protons. What's 53 protons?
Is that bromine?
Let's see, is that right? No, it's iodine. 53 protons is iodine. There it is.
Okay, iodine.
All right, iodine. 53 is the mass number, or sorry, the atomic number of protons. What else?
54 electrons.
So where do we write that?
Well, you don't write a number, do you?
No, you just write what?
A negative sign.
Like negative charge right there with the ion showing it that has extra more electrons than protons. All right, and then what's left?
Number of neutrons?
74. Do I write that up here?
I guess.
Nope. Up here goes what?
Oh, protons plus neutrons.
Right, so we have 53 plus 74. That is our 127. So this is iodine 127, the iodide ion, right? It goes from iodine to iodide when it becomes an ion. C, the ion with the atomic number 15. 15. There it is, phosphorus. Mass number 31. So how many neutrons is that?
16.
31 minus 15? 16, okay, right. So phosphorus, 15, 31. Any charge on there?
It says it's a 3 minus charge.
Very good. So that's easy to know, 3 minus charge. How many electrons does that end up having?
31 minus 3?
Not 31 minus 3, but what?
Oh, 15 is the number of protons.
That's right. So 15 is the number of protons. For phosphorus, 15 protons and 15 electrons if there's no charge here, right? Whoops. Got to scoot this over so you can see what I'm writing here. Ooh. Oh no, that's not what I wanted to have happen. Okay. 15 protons, 15 electrons would mean there's no charge there, right? Let's see, let's bring that back on. 15 protons, 15 electrons. What number were we on? Right here, right? And a minus 3 charge. Okay, so that's just the phosphide ion. Very good. All right, letter D. Ion with 24 electrons, 30 neutrons, and a plus 3 charge. It didn't tell us how many protons.
Well, you can't do it then, can you?
Is there another way we can identify number of protons?
Well, I guess if it has a plus 3 charge.
Yeah.
And we know that it has 24 electrons.
Very good. So if it has a plus 3 charge and it has 24 electrons, that's enough information right there, right? So it has a plus 3 charge. Let's try that again. Plus 3, 24 electrons. How many protons must it have? Think about that. What does it have more of? Does it have more protons or electrons?
How can you tell that?
Is it from the positive charge? Doesn't that tell you that it has more protons?
Oh, yeah, okay.
How many more?
3 more. Okay, so 27 protons?
Very good. 27 protons. So whatever our X is, 27, and it has a +3 charge here. And neutrons, does it say anything about neutrons?
30 neutrons.
So 30 plus the 27, 57 is the mass number. Nucleons, things in the nucleus, protons and neutrons, right? That's their 57 there. Okay, and what else? What element is this? What is X?
Do we just look for 57?
Not 57, that's the mass.
Oh, 27.
That's right, cobalt. So this is a cobalt 57 with 3+ charge. Cobalt ion with a 3+ charge. Good. All right, so 12. Write the symbol for each of the following. Same stuff, right?
Yeah.
Okay. The ion with a +3 charge, 28 electrons, mass number 71. I know the mass number is 71. We have 28 electrons, a +3 charge. I can write that in there. 28 electrons. How many protons does this have?
It doesn't say.
That's right, but we can figure it out, can't we?
Oh, yeah, because the number of protons is 3 more than the number of electrons.
Very good. And we are told that it has 28 electrons. So 28, 29, 30, 31 protons. 31 protons plus our mass number 71. So there's 40 neutrons, right? And a +3 charge. What kind of element? What do we put in there for X?
Oh, we just look for 31.
Very good. So it's gallium. So this is a gallium 71 with a +3 charge. Okay, good stuff. B. Ion with 36 electrons, 35 protons, and 45 neutrons. Okay, 35 protons, that's pretty straightforward, right?
Yeah, is it? What is that one over there?
Let's see if we can scoot this over a little bit. Bromine. 35 protons, bromine. 36 electrons, so that we know that there's more what? Positive or negative charge?
More negative charge.
Very good. Bromine, -1 charge, 1 more electron than there is protons, and a 45 neutrons, so 45 plus the 35, that is, right, 35 protons, so 70, 80. So it's bromine 80 with a negative charge. All right, C. The ion with 86 electrons, 142 neutrons, and a +4 charge. So, how many protons if we have a +4 charge?
Is it 4 more?
That's right, 4 more than what?
Then the electrons, 86, so 90.
Very good. So our atomic number is 90. We can look for that down here. There it is, thallium. Thallium, atomic number is 90. Our mass number, what's our mass number?
142 neutrons.
It's not 142, but 142 plus the 90, right? So 90 plus 142, 232. So thallium 232. And is there a charge on this species?
It's a +4 charge.
Very good. Is that, yeah, +4 charge. So 4 plus charge. So there's our species that's being described there. Okay, so now the last one, ion with a +2 charge, atomic number 38, and mass number of 87. Atomic number 38, that's a giveaway, right?
That's the number of electrons, or protons. That's the number on the periodic table.
Very good. So we're looking at strontium here, right? Strontium, is it strontium 38?
Is that what we call it?
No, we call it the mass number, right? Strontium 87. 87. So 38 is the protons. 87, how many neutrons does something like this have?
88, 87 minus 38.
Very good. So 87 minus the 38 gives us our 49. So we got 49 neutrons. So 38 protons, 49 neutrons, protons like that. How many electrons?
There's a +2 charge, so 2 fewer.
That's right, 85. So plus 2 charge. So it has 85 electrons and 87 sorry, 36. 36 electrons, 38 protons, and that's what gives it the +2 charge. Okay, good stuff. All right, so, whoops. Oh my goodness, where's Teams? Get rid of that thing. All right. Okay, 30, which one we do? We just finished up 12. All right, 16. Determine the number of protons, neutrons, and electrons. All right, we need to do protons, neutrons, and electrons for all of these. Okay.
You tired?
Yeah, sorry. Okay, here we go. Protons, neutrons, and electrons. Atomic number 9, mass number 18, charge 1. So here we'll do our favorite game. Protons, neutrons, electrons. A, B, C, D. Okay, let's start off with those ones. So atomic number 9, is that protons?
Yeah, that's protons.
Very good. So 9. Mass number 18.
That's protons plus neutrons.
So neutrons is 9. And electrons, are there more electrons or more protons?
How can I tell if there's more electrons or protons?
Well, if there's a charge, then the charge will let you know if there's more electrons or protons, because if it's more positively charged, more protons. More negatively charged, more electrons. Okay? So is this one more positive or negative?
More negative.
So it has more electrons. How many more?
1, -1.
Very good. So 10 electrons. Good. And then we could identify that species, right? That is an atom of, or an ion of fluorine. It's the fluoride ion, right? 9 protons there, 9 here. All right. All right. Atomic number 43. That's the number of protons. Mass number 99. 99 minus the 43. 56. That's the number of neutrons. And then the charge. Tell me about the charge.
+7.
All right. So what does that mean?
7 more protons than electrons.
So 43 minus 7, 36. That is the number of electrons. All right, C, 53 is the atomic number. That's easy. Mass number, atomic mass number, 131. So 131 minus 53, that's the number of neutrons, 78. How about the charge here?
C, we're looking at a -1 charge.
So 1 more electron, so 54. What kind of atom is this?
Is that iodine?
Very good. 54 electrons is the iodide ion. Good. D, atomic number 81, 201, plus 1. All right, 81. 201. 120. And electrons, plus 1. So what are we talking about here? Where's 81?
That's thallium.
Where at?
Right there.
Okay, so thallium, 81. So it's a plus 1 charge on the thallium. So we have 80 electrons. Okay, very good. So thallium. All right, and E there, we've pretty much done that in most of these. And those ones we didn't get, you can go back and get. So good job. 17, the following are properties of isotopes of 2 elements that are essential in our diet. Determine the number of protons, neutrons, and electrons in each of them. 26, atomic number, what's that tell us?
Number of protons.
Very good. Mass number 58.
58 minus 26 is the number of neutrons.
Good. Plus 2.
26 protons, 2 more than electrons, so 24 electrons.
Very good. And what element is that? What ion? What kind of ion is that? 2 plus charge on the 26. What is that?
Well, it's a iron plus 2.
Very good. Iron ion. Good. 53. Atomic number 53. What is that?
That is the iodine again.
Good. Mass number 127. The number of protons, neutrons, and electrons. So how many neutrons?
127 minus 53.
Put that on the calculator. 127 minus 53. 74 neutrons. Good. Charge minus 1.
Yeah, that means it has 54 electrons.
One more negative charge than positive charges. Good. 18. Give the number of neutrons, protons, electrons in a neutral atom of each of the following isotopes. Protons,
5,
electrons.
5.
Wait, did these say these are neutral atoms?
Yeah, so they're always going to be the same protons and electrons, right?
That's right. Same protons and electrons. And this number down here is going to be protons, so this is going to be pretty straightforward, right?
Yeah.
And then this number minus that will be what? The top number here minus the bottom number?
That'll be number of neutrons.
That's right. So 5 protons, 5 neutrons, 5 electrons. Protons, 80. Electrons, 80. Neutrons, 80. That was easy. No, not 80. 110, right?
190 minus 80, you mean?
Is that a 199?
Oh, 199.
Yeah, 199 minus 80. Okay. So 199 minus 80 is the number of neutrons, and that's 119. Okay, copper here, 63.
29 protons, 29 electrons. 63 minus 29 is the number of neutrons.
Okay, 29 protons, 29 electrons, 34 neutrons, right?
Yeah.
Okay, awesome. All right, what do we have here?
Ooh, carbon 13. I know about this one.
What do you know about carbon 13?
It's the one they use for dating different things that are still alive, right?
Yeah, well, I mean, that's right. You can tell when something died by the amount of carbon 13 it has left, because generally it should be constantly consuming carbon from either eating plants or other things that have eaten plants, and the plants are consuming the carbon dioxide from the air, and the air, carbon dioxide in the air, has a natural abundance of carbon 13 because of its exposure to UV rays at the top of the atmosphere. So, yeah, carbon 13 is a pretty cool tool that we have. So, how many neutrons in an atom of carbon 13?
7. 13 minus the 6.
Good. Excellent job. And protons and electrons would be just 6. All right, scandium 77. Oh, no, selenium 77. Selenium 77. All right, what do you think?
34 protons, 34 electrons, 77 minus 34, 43 electrons.
Very good, 43 electrons. Okay, give the number of protons, electrons, and neutrons in the neutral atoms of the following isotopes. Oh, we're still doing the same thing? So, lithium. 3 protons, 3 electrons, 4 neutrons?
Yep, that's right.
All right, you do this one.
TE, what's that?
Is that tellurium? Let's see if we can find it on here. There it is, tellurium. Okay. Fifty-two protons, 52 electrons, 125 minus the 52 is the number of neutrons, 73 neutrons. All right, your turn. Silver.
Silver, 47 protons, 47 electrons, 109 minus 47.
There it is.
62 neutrons, 62 neutrons.
Good job. Okay. This one's easy. I'll do this one. Nitrogen, there it is, 7. Protons, electrons, 7. Neutrons, 15 minus 7, is that 8?
Yeah, that's 8.
Okay, that's the number of neutrons. Good.
Phosphorus 15, no, phosphorus 31 or phosphorus 15? What do you call it?
You always call it after the mass because that's the thing that can change. To say phosphorus 15, that'd be silly because you know how many protons if you have the periodic table. So you wouldn't have to say phosphorus 15. You would just say the mass number because the mass number can change because different isotopes can have different number of neutrons, right? So phosphorus 31 is what we call it.
15 protons, 15 electrons, and 16 neutrons.
31 minus the 15 is where we got our 16 neutrons. Good. Okay. An element has the following natural abundance. 90%, 90.92% abundance of that, 0.26 abundance of that mass, and 8.82 abundance of that mass. And we want to calculate the average atomic mass. Okay? Well, some people would say, well, just add them all up and divide by 3 because there's 3 different masses. But there's not 3 different atoms, right? There are a lot of different atoms in the hat, and they pulled out a lot of them. And it wasn't a third was this, a third was that, and a third was that. If it was just a third, a third, a third, then you would add them up and divide by 3, and you'd be fine. But what it was 90.92 were 19.99. That's a pretty high percentage. So the mass is going to be very close to 19.99. All right? So the way that we determine this is we have to make sure we take the mass, or sorry, the percentage, 90.92, times it by the mass, that it is 19.99, and then add that to the 0.26 times 20.99, and then add that to, oh no, we're running out of space, 8.82 times 21.99. Now we divide all that by something, right? We're taking the average. We're still just taking the average. But it's like we drew 100 things out of the hat. And 90.92 of them, and that's why percentage, that's what percentage means, right? 99.92 had that mass, that number had that mass, and that number had that mass. So if we divide by 100, because it's like we've taken 100 things out, then the result here will be the average atomic mass. Okay? So I'll put that in the calculator. I'll do 90.92 times 19.99. And then I'll do 0.26 times 20.99. And then I'll do the last one, 8.82 times 21.99.
Now you got to add those all up.
Yeah, we got to add these all up. And then I can divide by my 100. So that's 20.17. And that will be my average atomic mass. AMU, atomic mass units. Okay? Good.